Hello, my friend. You are welcome to my channel. If you're someone who is looking to understand what is deep neural network, so this is the video for that. In my previous video, I had talked about the mathematical intuition about deep neural network. In this video, I will talk about more like a graphical or geometrical representation or graphical intuition. If you really want to understand that what the deep neural network really does behind the scene graphically, this video is for you. And also I'm talking about the basic difference between ML project and deep learning project. Okay, so this video is the continuation. If as you know that we are running a course on generative AI, so this is the part of deep neural network. Okay, so let's get started and let's understand in this video what is the graphical presentation or graphical intuition behind deep neural network. Let's get started. Okay, so let's start. What do you mean by deep neural network? Okay, I think already mathematically I have already shown the formula of those things. Let us understand graph wise. So graphically, if I talk about graphically what is deep neural network, okay, so in order to explain that concept, I'm using some graph just to explain certain things and let us understand those aspects. Let's suppose I'm giving example with respect to let's suppose I have two classes x and y. Okay, I have two features. Okay, and let's suppose I have a couple of, suppose I have two classes. Let's suppose I am doing a classification problem. Okay, so let's suppose I have uh, two types of features or two types of groups or cluster. Okay, if you remember our previous example, let's suppose I have this kind of data. Let's suppose I have this kind of data. One feature was like what is the salary of people and what city they belongs to and the purchase happen or not happen. Okay, purchase. Okay, so if purchase is 1, it means purchase happen. If purchase is 0, it means purchase not happen. So it's more like a sales data. Okay, based on their salary, based on customer city, we can predict whether purchase will happen or not happen. Let us understand this data. So this is our one cluster. So green represents the purchase happen. Let's suppose this is a green cluster which happens, purchase happens. Now this one, red one, let's suppose this is another people, group of people, they belongs to this cluster. Okay, and let's suppose they purchase not happen. So this is representing purchase happen, I mean 1, and this is representing purchase not happen. Okay, so let's suppose if I ask you, the task is that I want to do classification kind of job, whether I want to predict purchase will happen or purchase will not happen. Okay, and I want to build a model, I want to train my model, okay, based on this data set. Okay, so graphically, I hope you know the mathematics, but graphically what we do in this case, okay, because it's a very simple data set in this case. So you can see that here graphically the meaning of network or the meaning of a model, the training of model is what? To find a boundary. Okay, so graphically what we do basically in case of classification, we find a boundary. What is called? We try to find a boundary so that we can separate our whatever cluster we have. Let's suppose I have two clusters here in this data set. So how to find the right boundary so that we can separate these two classes. Okay, and whenever we find any new data set, okay, so based on that boundary I can predict whether this data set will fall into a boundary A or boundary B. Okay, so let's suppose here in this case you can see that this pattern okay, that these two groups of people can be easily separated by a straight line. Okay, so why straight line? Because these two data sets are linearly separable. Okay, uh, it is by, because you can see the patterns, the data pattern here. Why I'm drawing a straight line? Because by seeing the data pattern, I can see that data can be, it is a linearly separable. Okay, I mean I can easily separate my this data using a straight line, or if it is in a in 2 dimension I can do straight line or plane. Okay, so it is a linearly separable data set, but I can easily draw a line. Okay, so actually So how to find this line? So training a model actually meaning that we are finding our straight line. I mean, we are finding a boundary between these two data points, between these two clusters. Okay, and this boundary will determine that this belongs to, for example, this green one. Okay, this belongs to purchase reason, and this red one purchase to not purchase reason. Okay, and let's suppose I find new data point. Let's suppose we have trained the model. Okay, and suppose in the live, in the production, I have a data point. Suppose this data point. Okay, this data point, and let's suppose this data point is falling here. Okay, because I have fixed my boundary. I have trained my model based on the data, and after training, after doing a lot of mathematical calculation, I found that this line is a best line. We can build a boundary, and we can separate two data groups. So based on this boundary, I can determine that new data point. If I'm finding new data point, I mean this data point is uh, belongs to this group. Okay, because these all points are in the upward direction, in this region. So if this point is falling in the same region, I can assume that, or I can predict that this data point is like a purchase. I mean, if user has this feature, I mean, they have a purchase, they have purchased the product. Okay, on the contrary, if I find that any data point which is falling in this region, because this straight line is creating two regions. Okay, if something falling in this region, I can predict that, suppose this is my new data point, so I can say that these people will not purchase. Okay, so you can see that whole purpose. Okay, our whole purpose of training a model or building a model is what? To find a to understand the data pattern. Okay, my model will understand the data pattern, that what kind of relationship they have in the pattern, whether we can separate by a line, we can separate by a hyperplane, we can separate by a plane, or we can separate by some curve. Okay, how? So my model, the deep neural network, okay, they try to understand the pattern, complex pattern. Okay, based on the data, whatever features you have, your model will try to understand the complex pattern inside the data, whether they have a linear pattern. That there could be multiple things. Okay, in the data set, there are multiple possibility. They can have a linear relationship. Okay, then can have a non-linear relationship, right? There are two possibility. If they have a linear relationship, then I can draw a line or plane or hyperplane. Or if it is a non-linear relationship, okay, then it can be some curve. The boundary can be like this curve, or boundary can be like this kind of curve, this kind of curve. There could be multiple possibility. That depends upon the data. Okay, so the whole purpose of neural network, graphically, if you really want to build a concept, that actually what are you doing by training a model. If I say that I'm training a model on my data set, so what exactly you're doing? You're trying to find a best boundary. First of all, your model is trying to understand the relationship, maybe what kind of pattern they have. It's a complex pattern, it's a simple pattern. They're trying to understand the whole pattern. Okay, and based on the pattern, they will draw a line, they will draw up, you can see a boundary. It can be straight line, it can be plane, it can be hyperplane, it can be a curve. Okay, that is the whole purpose. If you really want to understand graphically or geometrically, they are trying to find a pattern, they're trying to find a figure or some curve. Okay, so that it can separate or it can build a boundary. Okay, this is the whole geometrical concepts. Let me give another example. Let's suppose, because it was a very simple data set. Okay, it was a simple, you can see that first of all it tried to find the pattern, and it found the pattern is a linear pattern. This data set is a very simple pattern, so they can find a straight line and they can separate our groups of data. But in case of complex, okay, so why these neural network are so famous? Okay, I will talk about that. Why neural network are so famous? Because they can find very complex pattern. This is why it is so famous. They can find very complex pattern in the data, which maybe machine learning is not capable. So why network is so capable? Because they find the complex data, and based on the complex data, they can find the boundary. This is why it is so popular. Okay, and it can work on massive data. I will I will talk about the difference also. Okay, first of all, let us build the intuition. So this is what it is so famous. It's to try to find the complex pattern. Okay, let's suppose this one. I'm giving one more example. Let's suppose this is my data. Okay, and in this case, it is not a simple data. It's very complicated relationship. Okay, so let's suppose I have one group. Okay, let's suppose this group. Let's suppose circle. Okay, this is one pattern, one data here, one data here, one data here, one data here. Okay, and it is suppose in a multi-dimension. It can be have multiple features, 1 2 3 4. That is the okay, that's a part of difference. So that is the beauty of the neural network. You can put any kind of features, 1000 2000 3000 features. So it can be multiple dimension data, and if it is a multiple dimension, then the pattern become very complex. So let's suppose this is one group which I'm representing by this way, and let's suppose I have another group, okay, which I'm representing by like this. This is one group, one set of data like this. I'm just drawing at random, okay. I'm just randomly I'm drawing something here, but let's assume that I have this kind of data, okay. And you can see that just looking at the pattern, the data, it is not very, it is not a simple data. It's a very complex data, right? You can see that it's a very complex data, right? And it can have multiple dimension. It can have multiple dimension. If I say multiple dimension, I mean it can have multiple features in your data set. Okay, it can have 200 300, it can have multiple features, and that is why neural network is so capable of handle multiple features. Okay, so here you can see that. So your network graphically, if I really want to understand that, if I suppose if I train my model on this data set, then what exactly your model is doing, let us understand that. So I told that it will do first thing. First of all, it will try to understand the pattern, the underlying patterns in the data, pattern in the data. Okay, maybe because this is very important. If you don't understand the pattern, then how you will find the boundary? Okay, I mean how the features are connected or in multiple dimensions, right? What are the different patterns in the data, whether it's a linear, it's a complex, it's a circular, it's a elliptical, it's a rectangle, right? It's a triangular. What kind of pattern they have, what kind of pattern they are forming? Okay, so graphically it can be any pattern. It can be kind of they're trying to understand the pattern, and based on the pattern they will try to find how I can separate and what can be my boundary graph. Suppose first it will try to find the pattern, and let's suppose it discover this is the pattern. Okay, and based on the pattern, then it will discover, find the right graph, or I can say right boundary. Okay, to predict, or you can say to classify the two segment, or to predict the next figure, something like that. So these are two things. Okay, first they will try to find the pattern in data, and based on the pattern, what can be the right graph or right boundary, so that I can separate my data set. Okay, so here let's suppose I'm giving this, I just want to build this intuition. Let's suppose I have multiple layer, because you know that this is the architecture, right? I have already discussed in my previous video. The neural network has multiple hidden layers. Okay, this suppose in the first hidden layers I have 3 neurons, or I have 5 neurons. Then I have a second layer. Okay, in the second layer I can have some neurons, and third layer, right? I can go deep. That is why it is called deep neural network. I can go any, that depends upon the data set. I can go multiple layers. Okay, and finally I can have an output, and this is the input layer, right? So you can see that I have multiple layers of hidden layers. One, this is the first layer, this is the second layer, third layer, fourth layer, and so on. You can have multiple layers. Okay, so how the network work? Okay, first, every layer, you can see that every layer, maybe if data is very complex, then maybe you have to build multiple layer. Okay, and the first layer, okay, first it will as I told you that it will try to find the pattern. So how it find the patterns? Okay, maybe at the first shot it will not find the right pattern. I mean, let's suppose, let's pretend that I'm just drawing this. Okay, let's suppose my actual, let me change the color. Let's suppose my real boundary, after a lot of trainings, I found that this is the my model is trying to find predict this boundary. So my somehow it is trying to separate these two classes using this boundary. Let's suppose after training, I found that this is the right boundary which can separate my data point. Okay, so it will draw this kind of circular kind of graph. Okay, and if suppose any new data point is coming, okay, let's suppose any new data point came, suppose any green data point, okay, then it will do separation that this point is in this. So you can see that it is creating two reasons. Okay, one reason is outside this circle, and one reason is within the circle. Okay, so if anything is outside the circle, I can say it's a green portion, I mean it is purchase happened, or which is within the circle, I can say it is not purchase. Something, I'm just hypothetically I have drawn this graph just to explain you the concept. Okay, so let's suppose hypothetically I found after the training this is my right graph or right boundary. So how it happened, okay, how the network is able to find this, draw this complex circular kind of pattern, okay, because of network, because of multiple hidden layers. Okay, so first hidden layer, you can see that this first hidden layer, maybe first hidden layer will find, maybe it will draw something like that. Maybe at the first layer it will draw something like maybe something like a straight line, something like this, something like this kind of curve, your first layer. Okay, second layer, it will add more complexity. So at every layer we are adding more and more and more complexity in my data. So first layer, it is not able to build the right curve which is supposed to build after the training. So maybe second layer, okay, suppose the first layer, this first layer is bending your curve. Okay, it is creating some bending like this. Okay, maybe the second layer, it will do more bending. Suppose after the second layer my curve will be like this. Let me change my color. So after first network, first hidden layer, suppose it is able to find more bending. Okay, suppose like this, I'm just drawing hypothetical. Okay, it is not a any train. Suppose it is able to find like this. Okay, and the third one, it is able to find more like a more circular, a more bending. Okay, so the concept here I want to concept build here, the more you go depth, the more you build hidden layers like this, layer 1, layer 2, level 3, level 4, it will find more complex patterns. Okay, and the bending, it will try to bend more, and it will try to find the right boundary. Okay, this is what the model does. So graphically, what you're trying to do, first of all, you're trying to understand the pattern, the very complex pattern in the high dimension pattern, which I cannot show here. I'm just using 2 dimensions. Let's suppose you have 1000 features in the data set, you have 1000 dimension. Okay, so as a human we cannot see it, we cannot feel about it, 1000 dimension. So your model is trying to find the pattern, trying to find the boundary, and it happens with the multiple layers. Every layers, it add more complexity at every layer, and at every layers it will bend, it will do more bending, and eventually it will figure out this is the right graph after a lot of trainings. Yeah, eventually there a lot of training happen, and a lot of process which you will learn later. But graphically, this is what happens. Okay, let me show one example. This is a very good example. You can go to this website, Playground. Just do a Google search, TensorFlow, Google TensorFlow Playground. Okay, so it is very good. A lot of teachers give this example. It's a very good example to just build a geometrical or graphical intuition that how it works. Okay, for example, let's suppose this one. So let's suppose I have this kind of, you can see there are a lot of patterns here. Okay, they have given a couple of patterns data set. For example, this one, this is so complex pattern, right? It's a very complex pattern in the data set. So I have two groups. One is the this blue one is the red one. So it's very complex pattern. Okay, you can see that. So how to if I build network, let's suppose I have here I have 2 dimensions. Okay, let's suppose you can see that it has two layers. Okay, one layers, this is the first layer, this is the second layer, and this is the output layer. Okay, so this is the input layer, all your features, and it has 2 hidden layers. You can see it has 2 hidden layers. The first is this one, and this one and the output layer. Okay, so let's suppose I'm not I'm just using suppose one layer. Okay, let me remove this. Okay, so let's suppose I have two layers. Okay, and my model is very simple. Okay, I'm just taking two layers and two neurons in first layer, and and one neuron in the second layer. Okay, it's very simple data set. Okay, and here just run this. Okay, there are multiple things like what is the activation function. I'm taking value. You will learn everything right now. Here I just want to see the perspective, that how it find the pattern and how it form the boundary. Okay, so let's suppose it's a classification problem. I want to just I want to just separate these two groups, and just you run this. Okay, okay, if you run this, so with the help of this setup, it will try to find the boundary. You can see that it is running. Okay, so it is trying to find the boundary, that what is the what are the best graph I can draw, so that I can separate these two groups and I can find the right boundary. So you can see that it has done these are many epochs or many iteration. It's an iterative process. You will learn later how to do training, but it is doing a lot of loops. Okay, and in every loops it is trying to find the right pattern or right graph. This is what would happen. It's a iteration process. So right now 2000 epoch has run. 2000 uh, is already done. So you can see that it is, if I stop here, okay, so it is try to find this kind of pattern. Okay, you can see this kind of things, and I think it is still a lot of misclassification. What I do, I just add more layers. Okay, so that if you add more layers, it means you are doing more bending, or you are adding more complexity. You adding more layers in the hidden layers, it means you're adding more complexity, and it will understand more. If it has a very complex data, you're adding more hidden layers, then you're understanding more patterns. And if you're able to understand good patterns, then maybe your curve will be better. This is what the intuition. Okay, what is the intuition, what is the meaning of adding more layers? Now let me run again. See, now it is doing more kind of curve, and it is finding better kind of boundary in this case, because now I have added more complexity. Okay, now you can see that. See, you can see the bending. It is trying to bend more. It is creating more curve based on the pattern. Okay, and it will try to find the boundary, better boundary. So this is what happens behind the scene. Okay, it has 2000 epochs, 2004. It is still loss is almost okay. Let me stop it. Okay, so this is the boundary, my friend. Okay, this is the boundary they have. They understand the data based on these neurons, and they found this kind of boundary. If you really want to add more, let's suppose if I add more neurons, then maybe it will add, it will find more better boundary. Okay, now let us run this. So here what I want to establish a concept here, that the purpose of neural network graphically is to find the right, first of all they find the right pattern. They will understand the pattern, and based on the pattern they will try to find the right boundary. They will if the data is very complex, they will they will curve. They will create a multiple curves. Okay, because it's not a linear separable. If data is very simple, I can separate by a simple straight line, but if data is very complex, then I have to find a right curve, so that I can say, now let us see. I think this is the right boundary. With this 8 neurons and 6 neurons, you can see that they have find the right boundary now. Okay, you can see that all the yellow one, the all the blue one, they are falling in this region. Okay, the blue one, and this orange one, they're falling into this region. So they are trying to find the right reason. Okay, so this is the graphical intuition or graphical meaning of uh, the neural network. Okay, so I repeat, what is the meaning of that? First, it will depending upon the pattern. Okay, First of all, they will try to understand the pattern, whether it's a linear relationship, it's a non-linear, it's a graphical relationship, what kind of relationship. Okay, it can be multiple possibility. So first it will try to find the pattern, and based on the pattern it will find the right boundary. It can be straight line, it can be curve, and it can be any kind of curve. Okay, so that is why one thing, this is very important concept. A lot of people use it in network, that neural network, okay, neural network can solve or approximate any function. Okay, let me explain what is mean by mathematically. Okay, what is function, by the way? Function is what? Y is equal to fx, we call it function. So function is nothing but a relationship, right? If you know the maths, function is nothing but what is the relationship between x input and output. Okay, so how my output will change if I change my input. So what is the underlying pattern between x and y? Okay, this is called function. Okay, so if I really suppose I have this kind of data set, I have x1, I have x2, I have x3, I have x4, I have multiple data set. This is my x set. Okay, and I have, for this x set, I have given y set. Let's suppose I know what is my y1, my y2, what y3, y4, dot dot dot. I have my y. Okay, so I just want to build a function, okay, or I want to build a rule so that my function can explain the relationship or the pattern between x and y. Okay, so this is called approximation. Okay, so mathematically it's very challenging to find the pattern. It's how kind of pattern. So suppose if I say like this, if I x, suppose this is my x, this is my y. Okay, suppose if I say x is equal to 1, then y is equal to 1. If I say x is equal to 2, then y is equal to 4. If I say x is equal to 3, then y is equal to 9. If I say x is equal to 4, then y is equal to 16. Right? So are you able to find any pattern here? Right? Into 2 and 4, 3 and 9, 4 and x, 4 and 16. Okay, I think if you're smart, then yeah, the pattern is like this: x square is equal to y. You see the pattern? Okay, so what is the pattern between x and y? It's a square. Okay, so this is the maths, right? So because it was very simple data, so we can easily find out. But suppose we have multiple complex data, so how to find the relationship between x and y? So in that case, you can use network. You can use deep network. You can build any kind of network, any kind of layers, and it can find it will try to find the approximate. It is called approximation. I'm not saying it will find 100% accuracy. There's no 100%, there's no guarantee that there will be 100% accuracy in the model. But yeah, it can be, suppose you're finding 90%, 95%, that's also okay, right? You are doing, at least you are able to find the function which is very close to 90%, 95%. So approximation is very good, right? So that is why deep neural network can approximate any kind of function. This is a very important concept. Why? Because of I explained that, because of I show this graph, right? It is trying to find the right boundary, right pattern. So this right boundary is what? It's just like a pattern, right? It is trying to find the pattern between the data. See, if you're able to find the pattern, means you're trying to approximate the function. Finding a pattern, let me write this concept. Okay, finding a pattern in the data, finding the pattern is what? Finding a pattern in the data is equal to approximation. You are trying to approximate a function, basically approximate the function. So this is the concept, my friend. Okay, so graphically, actually it is trying to build it is trying to find the pattern, and based on the pattern it will find the right boundary. It means you're trying to approximate a function to find the relationship between the data. Okay, I hope I took a lot of time to explain this graphical intuition, but it was very important to explain because okay, because this is very important. Okay, yeah, so this was a graphical intuition. Okay, If you still have any doubt, in case of, I try my best to explain the graphical intuition. But if you still have a doubt, please post in comment. I will try to answer your questions. Okay. Now let us move to, without wasting our time. I want to touch upon another aspect here. Okay. So as of now, let me recap. As of now, we have touched upon what is the neural network. Okay, how it works, and what is the mathematical equation or mathematical presentation, like forward propagation, backward propagation. Though we have touched upon only the basic foundation, we haven't gone at very depth, okay, how it works, but we have basic understanding that this is how it happens. And then we understand about graphical intuition or geometrical intuition, because this graphical is very important to establish in your brain that what exactly you are doing. Okay. And this is very important concept you have to remember, my friend. Then deep neural network, basically it is trying to find the pattern in the data. It means that you are trying to approximate a function, you're trying to approximate the relationship between your data. This is what the conclusion is. Okay. Now let us understand. I know that a lot of people, you have already using ML, right? Now you might be thinking, okay, I have already ML, I already have a machine learning. Okay, it can also predict, it can also do classification, it can also do regression, right? It can do pretty much, it can do clustering, right? Pretty much, right? Then why I should learn about deep neural network? Why we require this, right? How many of you have this confusion or dilemma that why I should learn neural network? Why ML to hang, right? I can do everything with ML. Then why I need this? Okay, so let us understand the comparison. Okay, and especially guys, if you really want to make a career into generative AI, okay, then in case of generative AI, deep neural network concept is pretty essential. You cannot bypass, or I mean, you cannot bypass this relationship, these concepts, and you can master generative AI. Okay, so in field of generative AI, the application of neural network is massive. Okay, for example, you will learn later like what is the RNN. Okay, suppose you want to work in the NLP field, which is mostly we work in the NLP field in case of generative AI, by like we dealing with text data, image data, okay, speech data, right? Then this application is very vital. Okay, so suppose what is the RNN, LSTM, like transformer. So your generative AI start with a transformer. Okay, transformer model or transformer architecture. So guys, if you really want to understand the underlying concepts or architecture of transformer, how the transformer work, then I would say you should have the very fair understanding of neural network, because everything behind the scene, transformer is nothing but a neural network. Okay, so that is why for generative AI people, it's very important to understand neural network. Okay, now the question is, what is the difference? If I have already ML, right, then why I should learn about deep neural network? Okay, so in this section I'm going to give some very high level idea or high level comparison. Okay, that in ML project and in neural network project, what is the basic difference, how they work? Okay, what are the different things? Okay, so let us understand that. Okay, so I have a couple of points I want to talk about the basic difference. Okay, first thing I want to touch upon is the feature engineering. Feature engineering. I hope you understand what is feature engineering, right? Let me talk about the typical flow in ML. Okay, how we build ML project. If you have an ML background, you know that first you uh, gather the data. First you understand the data, you find the data. This data gathering can be from any multiple source. Maybe your client can do data, or you can find data from different sources, maybe from internet, from, it can be anything, right? If you understand, if you got the data, right, then what we do, we do a kind of cleaning the data. We do a cleaning the data, or you can say we can find outlier, right? What is the outlier in the data, right? And you do some outlier detection or outlier removal, something like that, right? And then once you've done that, then here you try to find that you can do also do scaling, like feature engineering, like you can do scaling the data, you can do normalization of the data, something like that. You can do feature engineering, okay? And then you find that suppose you have 20 features or 30 features or 40 features, right? We do EDA and we try to find the feature extraction. We do a feature extraction here, right? Feature extraction. So here our purpose is to find that which features has more weightage towards finding the prediction or whatever problem you want to solve, which feature has more importance. We do a feature extraction. There are a lot of mechanism. I'm not going to touch upon that. And finally, if you have done the feature extraction, then you build the model based on those data set. You build the model, okay? And once you build the model, then you deploy it into production and do prediction. This is the workflow, typical workflow in the ML projects, right? And but in case of in the deep neural network, there's some slight difference, okay? What is the how we do in neural network? Again, here again, it starts with the data. Data is important. So first we gather the data, same here, okay? And once we find the data, then we generally yeah, you can do outlier detection, you can do that. And generally here we scale the data. We do the scaling because in neural network, it is always good practice to scale or normalize your data, okay? Before feeding the data into network, okay? And here one thing which we don't do in neural network is we don't need to do feature extraction. Feature extraction is this step is not required in case of neural network, okay? Why it is not required? Because neural network, it will, I told right in the beginning, neural network is so capable, it will automatically try to understand the pattern, okay? Let's suppose you have 1000 feature, 2000 feature. Generally, the ML process will try to understand that which feature has more importance, which feature has more weightage towards my output, and we only take those features because machine learning has a problem that it cannot deal with multiple features, it cannot deal with multiple dimensions. This is the problem with ML, okay? This is not the problem with neural network. It can deal with any kind of features. So here basically this feature extraction, the task or the responsibility of doing the feature extraction is upon the itself on the neural network. But in case of ML, this is your task. This is the ML engineer task to understand the feature importance or feature extraction. You have to do manually. It's a manual work, okay? But in case of neural network, feature extraction is not your job. It is not your responsibility. Okay, the model itself, they are so much capable because of they understand the pattern, they understand the data, they will find the right weight, okay, weight, okay. They will find the right weight or right weightage, which feature has more weightage. They do a lot of training, they do backward propagation, and based on those training, they find that what is the right weight for right features. So this part is not required, and they will do automatically. Okay, and once you skill the data, this is not required. This portion is not required, and then you build the model. Okay, so what is the basic difference according to me? If you ask me, what is the basic difference of advantage of using deep network is that we don't have to do manual work like feature extraction part. We don't have to do manual work. It will done by automatically the network. They will find the right features. Suppose I have, let's suppose I have 1000 features in my data set. 1000 feature, okay? So in the ML, you have to figure out, it's a manual work. In the ML, it's a manual work to figure out which features I need to take, and I mean which feature has more weightage, and I will fit into model. I will build the model on those features. But in case of ML, in case of deep neural network, it is not required. It happens automatically. It happens automatically. Okay, so feature extraction is manual work in ML, but in case of DNN, in case of network, it is automatic happens. Okay, you don't know, okay, how it happens. There's a process behind that. It is called back propagation. It's very famous. and but it does happen. It happens automatically. Okay, so this is the biggest difference in terms of feature extractions, in terms of feature engineering in case of network and ML. Okay, this is the first part. Now let us talk about second part. The second part is about data dependency. This is very, very important, my friend. Data dependency. Okay, data dependency. So ML, okay, you might be thinking, okay, so if neural network can do everything which ML can do, then why I should use not only the neural network? Okay, see, maybe data is very important aspect. Okay, maybe not every company or not every organization has a massive data. Suppose you have a limited data. Suppose you have 1,000 rows, okay, or 2,000 rows or 20,000 rows. You don't have much data. You have limited data, but still with the help of ML, you can build a model. Okay, if you have only 1,000, 2,000 rows, 4,000 rows, and you don't have much data, okay, maybe your company is not able to spend much data, or maybe your application has no much data, okay, still you want to do prediction, still you want to do some kind of modeling, then you can use ML. So ML does not require much more data. Okay, but in case of neural network, it is not the true. It is a data hungry. It is called neural network is a data hungry. They needs more data. The more data you will give, it is better. Okay, if you're giving less data and you're building a network, neural network, it is not a good idea, and it can have a bias. Okay, it will produce a lot of bias in the model, and your model will not, maybe in the future data or real data, maybe it will not give a right prediction. Okay, that can be the case. So that is why it is always important to if you have a big organization, big company, like for example like Google, like Meta, they have a big massive data, they can play with that. Okay, so that is why this is very important to build this kind of model. And a lot of people say that why for example LLM, right? If you really want to build LLM, this is one of the prerequisite. You need massive data. If you don't have a data, okay, then you cannot build LLM. You cannot train LLM like OpenAI, like ChatGPT, like Cloud. This you cannot build LLM. Okay, so that is why you might be thinking. Just one thing I want to share with you: why company called like Meta, like Google, like Microsoft, they are frontier, they are pioneer in building the LLM because they own the data. These company are I think they own the world, almost all the data. Okay, so that is why they are very pioneer in that. I want to show one use case, okay, of network, deep neural network. I have very good example. Let me show that. It's a very good example of that. What happens? Yeah, this is a very good example. Okay, just search on Google. Okay, I have this link. Google apologize for the photo app racist blunder. Okay, what happened is a very interesting use case. Okay, Google has built one network to just to classify the images. Okay, and that time they had not trained the model on a massive data set. Okay, so what happened? One of the couple from Africa. This is very famous news. They took a picture from a camera, and the camera used to predict. Okay, they classify whether, for example, you can see that it's a car. Okay, it's a bike. Okay, so you can see that it classify like a it's very humiliating. Okay, uh, this couple, they classify as a gorilla. This is very humiliating. Okay, because it was not fault of about I mean the Google. Google has no intention intentionally to do something like this, because that model was not seeing this kind of data. Maybe that model has trained on some data. Okay, maybe this kind of data, this kind of aspect was not there in the data. So that is the problem sometimes. Okay, you just read this. Okay, so sometimes what happens, if you don't give right data to a model and you're building neural network, maybe in training data it can give a good prediction, but maybe in the production, in the live data, it can give a drastic or maybe it will not give the right prediction. Okay, that's the problem. Okay. Okay, let's talk about the third aspect. What is the difference? Okay, third aspect I want to talk about is the training time. Okay, training execution time. Okay, so as I discussed that ML can work on less data. They don't need very massive data like neural network. Okay, so the training time, generally we have seen that ML model, if you have done all the pre-processing, everything, you have done all the jobs, and suppose you want to build the model, right? So building the model is not very expensive, or it is not very time consuming. Maybe you can build a model in 1 day, okay, or maybe in 1 hour, maybe in 2 weeks, 7 weeks, okay. Generally it will not take more than 1 month, generally, okay. But it is not true with neural network. Neural network, as I discussed, it needs massive data, it works on the massive data, okay. So sometimes just to train the model, it can take more than months, okay, or more than weeks. So generally it's a difference that ML, neural network, take more time, training time, than ML. Okay, so this is the thing you have to keep. Suppose you are building neural network, you're training on the massive data. Your organization, your company should be okay with training time. Okay, this is what happens because they'll need a lot of infrastructure to build or train the model, which I will cover later. Okay, so this is one aspect, and the fourth aspect I want to touch upon, which is very important. Okay, interpretability. Interpretability. What do you mean there? Okay, one thing always call that neural network is a black box. It's a People always say that neural network is a black box. You don't know what is happening inside a neural network. Suppose you have drawn a lot of hidden layers, right? You have multiple hidden layers, and then you have an output, you putting input inside the models, right? And you don't know exactly this network, this hidden layers, how they are finding the patterns between the data, and how they are finding the lines or graphs, or how they are creating the boundary. You don't have a visibility, or you cannot. Let's suppose you build a model and you want to explain to your client. Your client is asking, hey, I just want to understand, how did you figure out I just want to understand the process, that which features is more important, which feature is less important, and how you have done the feature extraction. Can you explain the entire process? So that kind of visibility is not there. It's a black box. Okay, you don't know that what is happening inside the layers, how they are finding the pattern, how they are doing the mathematical calculation. You cannot explain to other, you cannot explain to client. So there's very less chance to explain. Okay, I would say no, you cannot explain at all. But in case of ML, okay, let's suppose you are building, you're using some ML algorithm, like for example, typically the decision tree. You're building a decision tree, you're building a random forest, right? You are building regression, right? So here, one of the best approach or best part is ML is what you can understand. Suppose decision tree, random forest, okay, model has some way you can find that how they have trained the model. I mean, how the model is thinking behind finding the pattern, what they are thinking, what they are doing, how they're finding the feature. This everything can be explained, or it is possible to interpret what is happening behind the scene. Okay, it gives you complete under the hood what how they are processing. Okay, it's not a black box. So ML is not a black box. Suppose you have a requirement that your client want to understand that, okay, if I have given this kind of data set, I just want to understand, man, how you have figured out what feature you have given importance. I just want to understand the whole your thought process behind finding those things, finding the patterns. Okay, then with the help of this algorithms like decision tree, random forest, You can explain on the PPT, you can explain in the call that this is the how it has done, this is how we have given this weightage to this feature, and you can explain it to the client, which is not possible in case of deep neural network. It is quite not possible. Okay, it's a kind of black box. You have no at all visibility that under the hood what is going on, how they find the pattern, which feature has given more importance. Though you can find all the weightage, okay, you can find all the weight, but still how they're finding the boundary, it is very difficult to interpret. So generally, it is called, it's a black box. It is not easy to interpret or explain to your client. This is the one thing you have to keep in mind. Okay. And fifth point, very fast, I want to cover is about the hardware needs, infrastructure. Okay. Infra, or I can say hardware requirement. Suppose you have a very budget constraint. You cannot like spend, maybe you are a startup or your company cannot spend more on infra. It can be budget issue. Okay. So ML, the best part is ML that you don't need very expensive infra. No required very basic, very complex infra. Even on the CPU machine, if you have a CPU machine, even on the CPU machine, you can train the model. This is possible. Okay, because you don't have a very massive data. Okay, so you can easily use CPU to train your model. It is quite possible, but this is not possible with neural network. Neural network is more like a capital intensive. I would say it requires capital. Okay, it's a capital intensive job. That is why not every company can build LLM. Okay, it's very capital intensive. Okay, and generally we require a lot of GPU. Okay, GPU, or generally in that we need a distributed system, because it is not that we are just using one CPU, one machine. Okay, on the cloud we have multiple machines. We are connected on the network. We are using multiple GPU in the machines. So it's a parallel processing. Generally, we do a parallel processing kind of job while training the model in production. Okay, so we need and GPU is very expensive. It is more expensive than CPU, and that is why it takes a lot of time. It has a lot of capital involved, and you need infrastructure for that. You need a distributed system for that on the cloud or from on premise. So it's very expensive, time consuming, capital intensive. Okay, so if your company is, suppose you propose some solution to your company, to your project or some your stakeholder, that hey, I have a solution, I want to build this solution, and I can build this solution by using neural network. I got the solution, but maybe there's a cost involved, right? For building this network, there's a cost, infra, the talent required, right? GPU required, time required. There are a lot of constraint to building this kind of network. Maybe your company is not willing to invest. Maybe the company has no much capital. There could be multiple reasons. Okay, so in that case, even though you have a solution, but because of this constraint, you cannot build a solution. So that's thing you have to keep in mind. It's very consuming, time consuming, capital intensive, and data intensive. You need a lot of data. There are a lot of constant thing you have to discuss about that. Okay, and sixth one I want to talk about very fast is library support. Library support. Okay, both has a good library support. Suppose in case of ML, you are working with ML, then generally we all the algorithm like random forest, whatever you're using. Generally, we have a scikit-learn, right? We have a scikit-learn library. So generally, we use scikit-learn library. It has plenty of all the libraries are possible available there. I hope you know that. And in case of neural network, okay, we use there are two kinds of framework. One is called PyTorch. This is the framework we have to use. Okay, PyTorch and Keras. Okay, these are all libraries. Okay, so again, PyTorch is from Meta, and Keras. This is TensorFlow, Kera, these are from Google. Okay, so these are kind of framework. Okay, they provide you all the like training, how to train the model using forward propagation, backward propagation. There are a lot of APIs they have. They comes with a lot of APIs. Okay, to build the model, train the model. So that's a difference. Okay, You cannot use scikit-learn. Scikit-learn is good for ML, all the mathematical statistical algorithm, but for network we use generally keras. Okay, and generally I have seen kera is more user friendly or more easy to use in kera, or it is more easy, it's more developer friendly. Okay, you don't have to do a lot of coding, it's very easy to learn. PyTorch is, but generally all the researchers, the people who do research in this field, AI and ML field, and they want to build something from a scratch, they want to build their own model or something, they want to experiment. So generally researcher people, they use PyTorch. It's a bit complicated as compared to keras. Okay, so kera is good for developer community, they everything is there. Okay, and last one I want to talk about, there's a last point which is my favorite, is the transfer learning. Okay, so this aspect is also very important. Transfer learning. But transfer learning, this is why nowadays generative AI is so famous today, and why a lot of people are adopting generative AI, because of transfer learning. Okay, how the transfer learning work, let me give some aspect here, some context here. Let's suppose you have built one model, suppose you have built some neural network. Okay, for example, suppose transformer. Okay, suppose bot model, you have some bot model. Okay, so somebody has already spent a lot of time, they have given a lot of data, they have done all the heavy lifting work, they already have done. Okay, and this model had they understood the data, they find the pattern in the data. Okay, and based on that trainings, whatever training it has done, let's suppose you have your own data. You suppose you're working in a bank. Okay, and bank has, suppose you are doing the claim processing, you have a claim data, and the claim data has its own pattern, they have your own pattern. Okay, and let's suppose you want to perform a task, NLP task, called NER, name recognition. Okay, this thing, you just want to find the pattern entity. Okay, something like that. I hope you know what is the NER work, right? Entity recognition, that's what you want to do. Okay, so here from a scratch, in this case, suppose you want to use a BERT model. Okay, so there are a lot of BERT model which has already pre-trained. It is called pre-trained model. It is already trained. Okay, so now next time when you have to perform this task, you don't have to build a model from a scratch. Generally, in the generative AI, I have seen that there will be very rare chance that you will build something from scratch. You don't need to build anything from scratch. All the models are already there. Already there are a lot of, it is called pre-trained model. Already models are there. Okay, your job is what? Take that model. Okay, and do a fine. It is called, this concept is called fine tuning. There are two things. Okay, there are two concepts. What is called pre-training, pre-trained model, and fine tune. Okay, we do fine tuning. So I have seen in generative AI, if you want to make a career in generative AI, 90% cases will be that you will do fine tuning. There will be very rare chance that you have to do pre-training. Okay, because pre-training is very capital intensive, time intensive. It takes a lot of time. You don't need to build a model from scratch. It takes a lot of time, a lot of money is involved. So generally you don't have to do that. So what we do, whatever we find a lot of pre-trained model. Okay, there are a lot of Hugging Face, there are a lot of platform. We download the model, and based on our data set, suppose this is my claim data. Okay, we fit this data to this pre-trained model, and we do the fine tuning. Okay, so what happens after fine tuning, this model can behave like my data. They understand my own data, which is private to my organization, and they can perform very well on your data. It is called transfer learning. Okay, so here you don't have to do scratch training, because if you do scratch training, it takes a lot of amount of time, amount of money is involved. Okay, this is the one advantage in neural network. There are a lot of models, they have somebody has invested a lot of time and money. Just take it, download it, do a fine tuning, show your data, and it will start working. This is the one advantage. But in case of ML, let's suppose you are building ML model, you have ML model. Okay, and you have shown the data, you have done a lot of training, you have spent a lot of time on building this model. Okay, so suppose I want to reuse this model. Suppose I have my own data, I have my own personal data, and suppose this model is doing classification job. Suppose it is doing classification job, and even I want to perform classification job. Okay, so this transfer learning is not possible. I mean, I cannot take this model and I can do fine tuning. So again, you have to do scratch, from a scratch. You will build the model. Okay, so that kind of transfer learning, which is possible in network or neural network like transformer, like BERT. Okay, this thing is not possible in case of ML. So this is the advantage. Okay, so that is why if you really want to build something in NLP space, okay, you have a text. In case of you're dealing with text sequence of data, then that is why it is always good to have transformer kind of model. Okay, which you can do fine tune, and you can show your data, and you can work with your company data, and you can get your job done without investing a lot of money and effort. Okay, so yeah, so these are some couple of differences in terms of ML and deep neural network. Okay, yeah, so I hope you got a lot of clarity in this video. Okay, so I hope now you have very fair understanding about what is deep neural network, what is the mathematical intuition, what is the graphical intuition, and what is the purpose of training, what happens of the trainings. Okay, and what is the basic difference between ML and deep neural network. Okay, and one thing I want to add here, neural network is not the replacement of ML. It does not mean that this neural network is going to replace ML. It is not like that. Both has its own importance depending upon the context, depending upon the situation. There are a lot of constraint, and you have to make a decision. Suppose you are at the position of taking a decision that which is good for my company, depending upon my infra, cost, human capital. There are a lot of aspects. Okay, so based on that, you have to take a call that which can be good for me. That depends upon business need. Okay, so yeah, so but these are some basic difference. I think you should be aware about this basic difference if you are working in this field. Okay, so this is all in this video, my friend. I hope you got a lot of clarity. It was really good, and if you really learned something in this video, you find something interesting inside, I will help you. I will urge you, please subscribe my channel. It will help a lot to grow my channel. Okay, this is all. Raj, I will come back with a new video, next topic. Till then, goodbye. Keep enjoying. I will come back. Thank you very much.